Hello everyone, good morning. And this is the first time in the last 2-3 years, this is the first time I'm seeing one conclave starting at exactly at 9. And big applause for the organizing team, because I think not even 2 years, 3 years, I think it's more than 5-6 years where I'm giving my exam exactly, I was there at 9. After that, I've never been in a conclave where it started exactly the time mentioned in the... So big applause again to the organizing team. So now, we'll be starting the first session by Dr. Vijay Dhamodharan regarding sports importance of technique when optimizing performance in sports. Please call upon the stage Dr. Vijay Dhamodharan.
Thank you, Dr. Chetan. So, good morning, everyone. Dr. Sarthak, thank you for having me here. And so he wanted me to give a little bit of an introduction about myself. So, a picture speaks 1,000 words. So I just have this video. It's a small thing, what we do. So this is called as Center of Excellence in Biomechanics. So we have it in Tamil Nadu Physical Education and Sports University, located in Chennai. So where we do a lot of research. We work with student athletes. We had worked with a few professional athletes as well. But it is more, we are not open for commercial application yet. So what you see is 3D motion capture system. So this is our university. So this is my our director and my mentor, Dr. Rajani Kumar. So that's his vision. And if you see the laboratory, I designed that laboratory. So along with my mentor's vision. So that is a very big lab. It's 21,000 square feet. And so we did cricket bowling analysis, and we did tennis. Especially if you go and see biomechanical analysis anywhere in India, what they do is only gait analysis. So gait analysis is okay, but how can you equate gait analysis? What the data that you get from a gait or walking pattern equate to a sports movement, which is highly complex. It is non-cyclical. It is erratic. You can't equate them both. So for every sports, we actually measure their skill. So this is my design. So we measure the skill. We measure the movement. We quantify the movement. So only when we quantify the movement, we can actually give some insights to the athlete who comes and pays a lot of money for a biomechanical analysis. Because in my honest opinion, gait analysis is good, but do gait analysis only when the athlete asks for gait analysis. So don't just do gait analysis because you only know gait analysis. So yeah, so we did many research, and this is called Qualisys. We have partnered with Qualisys, and we have also partnered with Kistler. They are the leading force plate providers, and with EMG also we have partnered. We are also doing many workshops now. We have recently started. In the next week, if you can, if you are all in Instagram or LinkedIn, you can search my name, or you can search CBTNPESU. Okay? There is a sprint workshop coming up where it will be the first of its kind workshop in the country. If possible, you can attend. So we did many things. Can I stop this? Can I go for the presentation? Okay. So, okay. So, what is sports biomechanics? So, sports biomechanics is a field where you study the movement. We quantify the movement. So, and I also work for a company called Movella, where we call it as bringing meaning to movement. So I study movement, and through studying the movement, I bring meaning to the movement. So this is a small introduction about where I work. It's based in Netherlands. So yeah, what made biomechanics, widely famous or widely studied is gait analysis. Obviously, it is the stepping stone for movement analysis. If you see, in the early 60s and 70s, when post the World War, and many war veterans, they had to replace their knees and hips. So a lot of replacement surgeries were happening. And after the surgery, the walking patterns of the patients were, very different from what they used to, how they used to walk. So based on the gait analysis and the motion capture technology was, introduced, and a mechanical engineer and orthopedic doctors who started working together, and they kind of practically invented a new field of study called biomechanical engineering or biomedical engineering in India. So based on that, they studied the movement pattern and they wanted to equate the movement. Like they wanted to bring the movement as normal as possible even before the surgery. So that led to the evolution of what we have now. So this is just the phases of gait. So if you see here, so you can see, so how do you capture movement and analyze movement? So you can see for a normal people, this is just a normal jog. So but if you take in in a motion capture analysis, you can see what is what is the pattern here, how he moves. See, if you take a camera and you record it, and if possible, if there's a slow motion, or if you use an open source software to make it a slow motion, you analyze the movement in slow motion, draw lines, play back over and over again, compare the options. Okay, this is a basic thing. It's like ABCD for motion capture. Okay, so where you just compare it. Okay, what is happening? How his hip is flexion, is laterally moving. So if you see here, okay. So see, so this is another movement, and this is one of the 3D motion software where you get you try to measure everything. You measure the angles. I didn't want to bore everyone who's non-technical people. So the blue line that you're seeing, it is the motion of the center of mass. Okay, so this is what actually motion capture is happening now in the high end, in the most advanced way. So you have seen us in the video that we are working with cameras, but now we are also moving out to the field. So then because sports is actually played in a field, not in the lab. So this is another technology called IMUs, sensors technology, inertial sensors. So this is an overview of what other sensors are there and how it is capturing the movement, how it is different from the cameras. Yeah. So how is this different from the camera systems? Camera systems has its own limitation, because you need your athlete to do the movement only inside the field of the cameras. You can't, if the athlete moves out of the camera zones, you can't track him. So if you see in a practical applications, it is a very big football field or a very big hockey field. You need hundreds of cameras to capture the athlete, so which is practically impossible, and it will also have a lot of disturbance for the players. So we use this technology to track the movement on field. So this is basic introduction. What will be happening? We'll be measuring their body segments and inputting them, and based on that, we'll be capturing the movement. So generally there are other companies as well who does motion capture using this technology, but inertial technologies has many flaws. So we get to we are the only providers in the world that has cracked this code, and it has been since 2014, where we are the only one who does magnetic immune inertial sensor systems. This is the basic calibration, like how you should stand before the motion capture. Okay. So yeah, before capturing the movement, we just ask them to move around so that the sensors are calibrated, and we'll check everything else is also calibrated. So what the lady moved there, this is how the software shows, and see, you can see that body is sinking inside. So this is called as a drift, which happens in many inertial sensors. There are a lot of inertial sensors in the market. So this is what happens. It doesn't happen with us because we have a patented magnetic immune algorithm which prevents this magnetic distortion. So yeah, see, you can see the difference from the left and right. Okay, so we can see there are many other aspects as well where using this technology we can capture individual athletes. So this is one of the demo that was done in USA. So if you see, so the movement here is, it's just a basic basketball dunk, but they were just measuring with the other with an international normative data. So you can see this is an individual inside laboratory assessment, and this can also be done in outside the lab as well during the actual playing conditions. So they're comparing with Mr. Irving and Durant's performance. He's a little bit, Durant was a little bit faster compared to Irvin. So yeah. So we can also do, we can integrate the, motion capture only, you can capture the kinematic variables. So for kinetic variables, we can integrate with the force plates and EMG sensors to capture the muscle activation and muscle force. So that will be wholesome system where you can completely capture the human movement. And so if you are a biomechanist, if you have experience studying the human motion, you don't just study kinematics. You study both kinetics and kinematics. Only then you will get an actual answer that you are looking for. So similarly, we can integrate EMG as well. So why I am talking about this now is, so we have been working with the camera systems for many years. We have visited many other labs who also study motion capture. So camera systems, the optical motion capture systems is the best. It is very, very accurate, but it has its own limitation. It is very, very time consuming, and you need lot of time to process the captured data. It takes lots and lots of time. So a little bit below the accuracy of optical motion capture system is the inertial motion capture system, with less time consuming for preparation and post processing the data, and also it can be used anywhere. It also has its limitation, like between the sensor and the receiver, you have to be at least the higher end system has a wireless range of 100 to 150 meters to capture it real time. But if you are going for a recorded session, then it doesn't matter. They have on-body recording option as well. So, okay. You see, what they're doing is, this is an motorsports where the movement of the crews, of the pit crew is being measured. So you can see they are just doing their work naturally, but the movement was captured, and you can see because improving the efficiency and time frame of the pit crew is a very big contributor for the performance in motorsports. Okay, this one is on field, and next is team capture. So if you have if possible, asking the entire team to wear the sensors, you can actually measure the entire motion, the movement of the entire team by syncing, so that you can know how an athlete moves individually and how an athlete moves in the game, in a training simulation or in an actual game. So this can also be done. So these are the data. For example, this is for ACL reconstruction pre and post. You can see how the movement, the blue one is the left, which is the injured one. The orange one is the right. So you can see the difference in the gait cycle of the kinematic data, and you can track it. If there's a, if you give a remedial a rehab exercise or training, so based on that you can see post 9 months, you can see how it is almost same. So that can also be tracked. So that is the major advantage of all the motion capture system. This is just on one of the analysis where you can see everything. Okay. So this is too much technique. So here you can also export the data in Excel or MATLAB or OpenSim, whichever you are comfortable with, to have a more detailed analysis with the data. Yeah. So and you can also use these systems to simulate. Based on what you captured, you can also simulate by giving some giving some of your own movement or a session or something, and predict what will happen to this athlete who moves this way. If he does this, what will happen? So those simulation can also be done and tracked. It can be used for prediction of injuries as well. So even clinical practice, we have using it in Europe. So capture reports and patient tracking. So it can be used in all the phases. We can track their progression. You can also include their exercise also. So we can track that as well. Yeah. Thank you. And I'm just forwarding it to the next person.